Okay, good afternoon, everyone. I think we'll get a start. I am looking for one last speaker, Ofri Orgad? No? Oh, you're here? Excellent. Fantastic. Okay, so we've got all four of our speakers. I'd like to welcome everybody to the last session of today, running parallel still to some others. It's ISMAR and monitoring. And just before we get started, there's some really good talks here. I've read the abstracts. With the onset of the 5G network and operation of MAR sites, characterization sites, drones, things like that, we're really in an exciting time for MAR and monitoring and really revolutionizing it. So I strongly encourage the next time we all see each other, more monitoring and examples of using particularly some of the 5G network stuff that we're hoping to see come through. So really exciting area. And so we'll start with an introduction to Giovanna di Filippis.
So good afternoon, everyone. I'm Giovanna De Filippis from Scuola Superiore Sant'Anna in Italy, and I'm going to present design and set in operation of a MAR infiltration scheme in central Italy within the framework of the LIFE ReWatt project. As we very well know, in several Mediterranean areas, due to scarcity of surface water, groundwater is very often the most important or the only reliable source of fresh water for several uses. So this is the case of the Lower Cornia Valley, which is located in central Italy, which is a typical Mediterranean area where the most important freshwater resource is represented by this alluvial coastal aquifer, which provides water for several uses, and so causing also conflicts among water uses in the agricultural, industrial, and civil sector. Here, the groundwater budget is also affected by the water needs of the near Elba Island, to which groundwater is delivered through a submarine pipeline. So within this framework, the groundwater resource in this area has been particularly affected by overexploitation, especially during the last 60, 70 years, resulting in severe head lowering, especially in the central part of the area. Here at the bottom of this slide, you can see the trend of the water level with respect to the ground surface, and you can see also very easily local minima during the dry periods. And another problem was related to the water deficit. It was estimated about 8 million of cubic meters between 1970 and 2000. And this in turn caused also problems on groundwater quality, especially due to saltwater intrusion, which because of which some well fields, especially near the coast, were abandoned. And also, we have also problems of land subsidence. So within this framework, the major scope of the LIFE ReWatt project is to develop a participated strategy for integrated water resource management in this area. So in order to restore and rebalance groundwater budget in this area. ReWatt stands for Sustainable Water Management in the Lower Cornia Valley through demand reduction, aquifer recharge, and river restoration. And it was financed by the European Commission with more than 2 million euros since October 2015. And Life Free Water strategy is based on two main pillars. On one hand side, we have 5 innovative demo actions which involve water saving in agriculture, in the civil sector, river restoration, wastewater reuse, and also managed aquifer recharge for environmental purposes, so in order to replenish the aquifer. And I'm going to focus on this demo action. On the other hand side, we have stakeholder involvement through dissemination, communication, training, capacity building activities, which will end up with the signature of a river contract for integrated water management in this area. Regarding managed aquifer recharge in Italy, actually there are several books which talk about artificial recharge of groundwater bodies. Since 1928, and up to 40 experiments can be counted from the 50s. Most of them are using induced riverbank filtration techniques, but still they are, all of them, they are unauthorized until 2013, because the first Italian regulation on managed aquifer recharge dates back to a very few years ago, 2016, and it lists criteria for granting authorization to enhance recharge of groundwater bodies in order to achieve a good quality status. The Life Free Water MAR plant, which has been, which is now in operation in central Italy, is the second one authorized according to this Italian regulation. Specifically, it involves an infiltration pond which exploits excess water from the near Cornia River. So the source of water is flood water, and for environmental purposes, so again to replenish the aquifer and to increase recharge, to rebalance the groundwater budget, with an expected increase of aquifer storage from 0.3 to 1.2 million cubic meters per year. Annex 1 of this Italian regulation lists also criteria which must be respected to grant authorization to set up a MAR scheme. First of all, a preliminary project must be presented. This is about an overall characterization of the study area from a hydrological, hydrogeological, hydrochemical point of view, and of the scheme type, of the source of water, and of the groundwater body involved. And then an executive project must follow about a detailed area characterization, the type of the MAR scheme, and the hydraulic, hydrochemical, and socio-economic impacts of setting in place this kind of technique. And also a management plan, a monitoring plan, and an emergency plan must be provided before getting authorization to set in operation such technique. So what was a pilot at the beginning actually became an actual engineering project, because we had to produce a preliminary project, an executive project, and so a lot of investigations were performed in the area, so involving hydrochemical monitoring on a monthly basis, geophysics, tracer tests, and so on. And this involved also the drilling of 15 dedicated piezometers around the pond to check groundwater quality and quantity. And these investigations were also supported by numerical modeling to evaluate the expected head increase due to the set in operation of this plant. And in particular, in this slide, I'm showing results from a simulation after 200 days of operation of this plant. So we expected about 900,000 cubic meters of recharge. These simulations were performed applying an open source and free QGIS-based platform, the FreeWatt platform. And so finally, this was set in operation. It basically involves an infiltration pond. No? Okay. An infiltration pond, which is located near the Cornea River in an area where the river already naturally recharges the aquifer, so in order to increase the recharge process. And the excess water from the Cornea River is diverted from the right bank of the river by gravity until a set of two concrete boxes. In one of them, a mass spectrometer checks the quality of the water diverted. In the other one, a 80 liters per second pump collects surface water towards the infiltration basin. The infiltration basin itself is actually made of two parts. First of all, there's a sedimentation vegetated pond for sedimentation reasons, sized 350 square meters. And then the infiltration pond, which is sized 1,600 square meters. And this plant became operative since December 2019. And so far, after a very rough period in 2018, we diverted about 400,000 cubic meters. And it is supposed to be in operation between October and the end of May, of course, while there's some water into the river. So these are some nice pictures of the ISMAR plant in operation. This is at the very beginning of the infiltration process. That is the vegetated pond, and this is the infiltration pond, and this is how it looks like when it is full of water. And a very innovative aspect of this system is a high-tech, high-frequency monitoring system, which involves a multi-parameters probe and a mass spectrometer to check the quality of the water diverted and to check groundwater quality, and a set of sensors around the pond to check also the effects on groundwater quantity. I'm not going into detail about this system because there's a presentation at the end of this session dedicated to this aspect. And the three institutions involved in setting in operation this scheme are also in charge for the management plan. So in particular, the Land Drainage Authority is in charge for basin scarification and plough on a yearly basis. Then the local water utility is in charge for pump and diversion system maintenance and problems related to the electrical works. And Scuola Superiore Sant'Anna, my institution, is in charge for sensor maintenance and discrete monthly monitoring. This is the discrete monitoring network. It is made of about 10 piezometers around the pond, which are equipped with sensors which collect data about groundwater quantity and quality with a frequency of 15 minutes, remotely controlled. And then there are also about 30 measurement points around the pond, so on a larger scale, which are monitored on a monthly basis. So far we didn't detect any negative trend in groundwater quantity and quality due to the infiltration process. So, in conclusion, the Life Suvereto MAR scheme is an example not only of intentional, but in our opinion also highly monitored recharge process, and this is needed also to safeguard people's perception on the operational safety of this kind of techniques, which allow to increase water availability in scarcity-prone areas. And I'm done, thank you.
Excellent talk, really good. Questions? It's hard to see up here. Oh, in the back?
There. Thank
You
you.
mentioned QGIS during your presentation. Oh, that's on. You use QGIS for some of your GIS work, is that right?
Sorry, who is speaking?
Over here.
Ah, okay. Yeah, sorry again.
Yes, you mentioned using the GIS package QGIS, is that right?
Actually, I used a plugin integrated in the QGIS for modeling. It's called FreeWatt.
Okay. And do you want to make some comment about how usable that was, easy, recommended for other people? Would you recommend that as a way of integrating modelling with GIS?
Yes, of course. Yes, actually, there are several experiences of integrating modeling codes within QGIS environments, of course, because you can have a look also at the geographical dimension of all your problems. So in our, according to our experience, this was one of the main strengths of using such a kind of tools. So yes, I definitely recommend it. Of course, if you need, I can give you more details about this platform, yes.
Excellent. Other questions? Got a couple minutes here. Well, I have a quick one. The MAR plant, is that set in an old oxbow or something? It looked like there was like an oxbow of an old historic river channel, or was it purpose-built, the MAR plant?
Sorry, what do you mean?
Is the MAR plant, was it excavated with machinery to make
Okay.
it?
Actually, it is located in already topographically depressed area,
Okay.
in a former gravel quarry in a former reach of the river. So, yes, of course, some works for excavation for removing, let's say, the fine sediments on the basis. But yeah, it was located in a already depressed area.
Yeah, excellent. And it's always nice to see that 1920s they were already doing this, and MAR is not that new really in a lot of ways. We're sort of repackaging it these days, so excellent. Okay, well, thank you.
Thank
Please
you.
thank her.
Thank you.